Hi everyone. So this video is going to be the screencast solution for Geeks problem of the day, and this problem is sum of upper and lower triangles, and it is an easy level problem. So a screencast basically means I'll be solving this problem live, and I haven't solved it till now. So I'll be solving this, and I'll also be explaining the solution if I'm able to solve it at the end of this video. So let's just start with the problem, and I just finished making the lead code problem of the day. So this problem says that we have been given a matrix of an end to end, and we have to print the sum of upper and lower triangular elements, right? So this is a very basic problem and a very simple interview type of problem, I believe. And okay, they've told us the definition, and the upper triangle consists of elements that are on the diagonal and above it, and the lower triangle consists of elements that are on the diagonal and below it. Cool. So yeah, so this was some rough work for the lead code problem of the day. Now if I draw a n into n matrix, so let's say this is, let's say this is 5 into 5, right? I believe, yes. So if you have this, and let me also create the diagonal element. So this is going to be the diagonal line, right? Now what we have here is, this is the ith row, right? And let's say I is equals to 0, I is equals to 1, and so on, it goes on. I is equals to 2. The value of n here is 5. On this 0th row, I believe we can go to this particular element, right? We can only go till this particular element, and on the 1th row we can go to this particular element, right? So this is the upper one, or this is the boundary till which we can go. So for the 0th row, it is going to be n minus I minus 1. So n minus, yeah, so j should be less than n minus I minus 1. So basically what I'm trying to do is, if I is denoting the row and j is denoting the column, so for the ith row, what is the maximum value of j I can go for the upper triangular matrix. So in this case, I believe this is going to be correct. J should be j should be less than n minus I minus 1. So n is 5, minus 1 is 4, and yeah. So for I is equals to 0, j should be less than 4, and it is 0, 1, 2, 3 and 4, right? So this was our boundary, and this is correct. And for the lower triangular matrix, we can start the value of j from this particular value plus 2, because this is the maximum boundary that we can go, right? This is going to be the diagonal element itself, and from the next element we can start the lower triangular matrix. So for example, in this particular row, let us consider I is equals to 2, right? So n minus I minus 1 is going to be n minus 3, right? So it is going to be 2. So we can only take elements which are at the column less than 2 for the upper triangular matrix. So that are these two elements, 0 and 1, right? Now we can start the lower triangular matrix from 2 plus 2. So 2 plus, we can start, yeah, so it is actually 2 plus 1, right? So we can start the lower triangular matrix from here. So this is going to be the diagonal element, and this is from where we can start, right? So this is, I believe, how you can calculate the values. And let me quickly code this for you. So I'm just going to calculate int upper comma lower. Both upper and lower are going to be 0 initially, and I'm just going to traverse through all the rows. So this is just a basic question of finding the values. So j is equals to 0, j is less than n minus I minus 1, j plus plus, and I'm just going to add it in the upper. So upper matrix of ij. Cool. So for, I'm just going to start this j from int j is equals to n minus I, j is less than n, and j plus plus, right? So this is going to be lower plus is equals to matrix of ij, right? Now I'm just going to return. So which one we have to return first? I believe we have to uh, return upper first, upper and lower, right? So this is how you can solve this problem. Let me quickly run this and check whether this is working or not. 20. Okay, so we are getting some wrong answers. Let's see what happens. So this is a 3 cross 3 matrix. So we are getting less values for both of them, right? Okay, so yeah, two things we have done wrong. First of all, I didn't read the sample test cases properly, so I've made one huge mistake. Actually, two mistakes. The first one being I have taken the upper triangle matrix to be this one, right? But they're not doing like this. Their diagonal is actually on the opposite side. So they have made the diagonal like this, and their upper triangular matrix is this one, right? So they're calculating it to be this one, right? So this is the first thing. The second thing is they're also including the diagonal in the answers, right? So this is going to be a difference. Although we don't need to change much things in our answers, so what we can do is we can do it like this, and we can also do it like this, right? So let's just try to run this once and see what happens. Okay, so we have still got some wrong values. Yep, so I'll get one value here. Yeah, so there has to be some changes, right? Okay, so let's just rethink this for a while. If I have a matrix like this, we're just going to redraw this. I should have like taken care of the sample test cases first. So if we have this for the zeroth row, if you're talking about the upper triangle, for the zeroth row we have to take all the characters. For the 1th row we have to remove one character from the starting, right? So we should correct this. This should start from I, right? So what is happening for the upper triangular matrix? For the 0th row we are taking all of the characters. For the 1th row we are removing one character from the start. So starting column should be equals to I. This is what I have done here now, right? I believe the upper part will be correct now. For the lower part, what we are doing is this one must be correct already. Let us just check whether it was okay. So this is also wrong. So for the 0th row we are taking only one element. For the 1th row we are taking two elements. Okay, so what we can do is instead of n minus I, we can just put I here, or maybe I plus 1. Right, let us just try to compile it now. So we'll see. Yeah, this works now. I'm just quickly submitting it. We'll see what happens. So you see it passes all the test cases and the solution is correct. So I believe, yeah, and that was it. The thing is, I did not read this particular part. I should have, and you should also, like, whenever you're solving problems, you should consider reading sample test cases. This is what I missed today. And what we were essentially doing was, the idea is not very different, but we were taking the triangles to be different. But instead, in the sample test cases, they have shown us what are the triangles going to look like, right? So according to what the triangle looks like, what I'm trying to do is, the observation is very simple. For the 0th row, for example, you are taking all the elements. For the 1th row, you are leaving one element from the start. From this 2th row, you are starting from this 2th index. So basically, for each row I, you are starting from the jth column, right? So for the upper triangular matrix, you can do it like this. Now similarly, for the 0th row, you are taking one element from the left. For the 1th row, you are taking two elements from the left. So basically, if you are at the ith row, you are taking I plus 1 elements from the left. So you can start from 0 and go till less than I plus 1 for the lower triangular matrix. And then you can just return both of them. And this would be the solution for this video. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video and don't forget to subscribe to this channel. It's because like you guys have a superpower and your like really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So I'll try to upload these kind of videos regularly and let's just see what happens. So that was it for today. Till the next video drops, keep coding, stay safe, bye bye.